Today, I will be speaking about prototypes and inheritance in JavaScript. To demonstrate code, I will be using the Chrome JavaScript console to provide a read, execute, print loop. In JavaScript, objects are created casually. Since JavaScript functions are first class, adding a member method to an object is as simple as adding another property. Here we have a simple implementation of an object to model a pancake. Here two methods are provided to simulate cake flipping. This is contrary to more strict object-oriented languages such as Java, where an object must be defined and endowed with methods first, then instantiated using the new operator. Using this method to create objects makes creating multiple instances difficult and generally violates the don't repeat yourself principle. As you can see, we had to repeat all of the code for the pancake to instantiate a second instance. Additionally, there's no facility for inheritance using this method. To bridge the gap between being merely object-based and object-oriented, JavaScript objects all have a prototype object associated with them. In early revisions of JavaScript, this function was only exposed through the new keyword. Each function has a prototype field, and objects created using the new keyword on that function have the prototype associated with the function that they were created from. So here we'll create a constructor, and then we'll add our pancake methods to the function's prototype. So here we have the pancake function, which acts as a constructor for pancake objects. And inside that function, there's the property prototype that we're adding member functions to. So now we can instantiate a cake such. You see that we have our pancake object with the fields initialized. We can check our pancake to see if it's been burnt or not yet. We can check to see if the flip function works as well. So now if we look at a cake, we see that has 31 flips. Apparently we flipped that pancake just too many times and it's burnt now. Since the prototype is a delegate object, modifications to the underlying prototype affect all instances using that prototype. In the case of objects created using new, we find the prototype through the constructor function. Here we'll modify the isBurnt test to change that to be 100. More than 100 flips will cause the pancake to be burnt. So as you can see, we've set that in the prototype. Now if we run the function again on our cake that we've already instantiated that previously was burnt with 31 flips, we find that now it is no longer burnt because the function has changed because we changed the prototype on its constructor. Some more modern JavaScript runtimes, the instances actually have this underscore underscore proto object that will show the prototype, which in this case has our member functions. What happens when a member is defined in both an object and its prototype? Let's perform an experiment by adding a syrup field to our pancake prototype. We'll instantiate some new pancakes for our experiment. Here we'll interrogate cake 1 for what type of syrup it's decorated with. We see that it's maple. If we change the type of cake 1 syrup, sucrose, we would see obviously that cake 1 syrup would have been changed. But what happened to cake 2 that shares the same prototype? We find that its value is the same as the prototype. We can see in cake 1 that now a field has been added called syrup, but if we dig deeper into that object, into the prototype, that there's still the value there of maple, which cake 2 is receiving by delegation because it doesn't have an overriding field. Object inheritance is a little messy in JavaScript. It requires some creativity as compared to Java, for example. First, we need a second constructor. The pancake.call method is actually function.prototype.call, which allows for the value of this to be provided while calling a function. Here it is used to chain the constructors. Does this feel like a hack yet? Modern versions of the EMCA specification define a method object.create, which will return an object with a specified prototype. We can use it to set up a delegation chain with multiple prototypes. Here, FPP, our fruit pancake prototype, delegates to pancake.prototype. Expanding this view allows us to see the fields that will be inherited. As you can see, these are the original pancake fields. We can set this as the prototype of fruit pancake. Adding functions to this new prototype will not affect the pancake prototype. Here we'll instantiate a new fruit pancake to see how our functions work. First, we'll test the original pancake functions. We can see that it is correctly finding the isBurnt function from pancake. Additionally, we can still flip the cake. We see the flips are 9, the fruit is pear, and it's still for the meal of breakfast. Our fruit-specific functions also work. Since the fruit is pear and the good kind of filling is defined as pear, this function returns true. Here we'll create a regular pancake to ensure that nothing funny has happened to our original definition. So here we'll check for a fruit pancake property inside of our regular pancake. It is thankfully undefined. Multiple level inheritance is supposedly possible, but far exceeds the scope of this video. Thank you for watching. I hope this information has been useful.